Okay, hi everyone. This is a bit of an explanation to help you out with your assignment, mostly for the video question, but we'll do a bit of an explanation here about the snail problem, just to make sure that people get the idea of it. And so you can see I've changed the snail question slightly from the one that I did before that was on your sheet, because this one here, the snail problem here, didn't involve composite equations, so this one will. So you can see here what happens if we look up here, where the snail goes here. So the snail goes up the wall 3 meters in 1 hour, and then it falls asleep, and it slides back down 2 meters. So we can see here, so the snail went up 3 meters in 1 hour, fell asleep, and then came back down to 1 meter. And that pattern continues along the whole way until we get up to the top of a 30-meter wall like here. So it just says here. So we're going to have to do 2 different equations today to figure out what we need to do. I haven't got a lot of room here, so I might have to try and do a few different things as we go along, and then we'll see what happens. So we're going to start off today by doing odd, and then when we get to the odd one, we'll have a look here. So I'll just get the pen working. I might do blue first today. Okay, so I'm going to do odd. So the odd pattern we can see here, it's only the odd numbers 1, 3, 5. There's enough there that we can look at the pattern if we do the number underneath as well. Okay, so when we want to find the general rule, we have to do, oh, that's moved on me, that shouldn't have done that. We're going to do y over x. So when we do the general rule, we actually want that just to, we do y over x here, and it'll help us out to find what number we need to multiply by. So as you can see here, our pattern's going up here. So let's go to the x, to the y first, sorry. Go down the y down the bottom, you can see the pattern's going from 3 to 4 to 5. So it's going up by 1. At the top up here, the pattern's going up by 2. So we know it's going to be out of a half. So we know when we find our general rule, we know it's going to be y equals x, and then we can bring this half down times a half. So it tells us what we have to times x by to find y. So we know it's a half. So what we can then do is we can substitute in, instead of x this time, we're going to substitute in 1. Off 1, we're going to have 1 times a half. Okay, so we know that's going to be a half. So what we have to figure out then is, well, but we know the answer, if we look over here, back to this one here, we know the answer here is 3. So if we're going to do the answer as 3, then we have to say, well, what do we have to say? We're going to put the answers down here. So what do we have to add to a half to make that equal 3? Well, then we just through our process, we know we have to plus something on, because we've done our times. So this is where we need to plus or minus, so we're going to add 2.5. So therefore our pattern's going to look like something like this. So our general rule is going to be, okay, so we put all that together. Y equals what we call a half x, because we get rid of the times sign when we use algebra. And then we have to add on 2.5. Right, there's a few people who write that a little bit differently, and a few people said, well, can I write it this way? Which was y equals x, plus 5 divided by 2, and that's fine, because they doubled the number and then just divided it by 2, and just rounded it off and made it look a little bit better. So that's quite acceptable. So that's how we would do it for the odd number. Of course, then we've got second. Yeah, okay, so here's the even number. 2, 4, 6. The pattern's going up by 2 there. And of course here it's going up again by 1 here. So the y is going up by 1, the x is going up by an even number. We're going to substitute in 2, because 2 explain that one. So if we go back here and we can say, see how I said, well, this when x equals 2, y equals 1? Well, that worked. So if we go along here and we say, well, that would mean that our general rule is going to be y equals a half x. And guess what? If we substitute it in 4, half times 4 is going to be 2. Same here, if we substitute in 6, half times 6 is going to be 3. So it follows our general rule. Okay, both of these ones here, I'll do them back in blue again. Neither of those ones are acceptable as our general rule. Alright, so then, okay, so what you'll probably see is that here is 54. Well, 54 is an even number. Now is going to be 27. So if I wrote down here, let's better get a colour. Let's make it black again. So half down here is going to be 27. Okay, and of course then the only one that doesn't really fit is this one, because when the snail wakes up after 54 hours and goes up 3 meters, and it's going to be top of the 30-meter wall after 55 hours. So that's the answer. Don't worry too much about that, because it doesn't got a lot to do with the solving of part B workings. Even just a photo would be more than handy. and then just put it in and just say, and then you can work your way through that one. Look forward to seeing them. Again, if you need any help, just give me a yell. I can help you certainly with the video casting and the screen casting and the things you need to do, but I can't give you too much help with solving the problem because we all like you to have to tackle that one yourself. Alright, have fun with it. Chat soon. Oops, have one. Oops, here, which is going to be the even number. I'm going to flip between, I might change colours for the even number actually, so just so we can get a really clear picture about what it is. Let's do green. So I'm going to do even. So then we have the even number. And the even number, we're going to use exactly the same process. Okay, so we're going to go back, if we have a quick flip back here and we use our rule before, again it's going to be going up by 1 over 2. So what we're going to do then is we have to say, well, do our general rule, y is going to equal x times a half. And this time we're going to substitute in 1 again. Sorry, we're not going to substitute in 1 because 2 is an even number. So the answer is going to be 2 times a half, and guess what? It equals 1. So therefore y equals 1. So a general rule we can suddenly say, so if we go back and swing. So our general rule is going to be, back on the pen, y equals half x, or half times x, whichever one you want to use. That's going to be our general rule here. Right, and if we go back to that, solve the problem first of all. Apply this rule here to 54 and we substitute in y equals a half x. Down here, we substitute this in here, we y equals half x, but this time we're going to say x equals 54. Well, a half times 54 is interested in now, but let's go to show. Go to this one. These are the questions I'd like you to answer in the video. So you can start to substitute priority for a second. So if you can answer these questions here, so these are the questions we'd like you to answer when you're making your video to solve, to so how you solve the problem, is how do you find the general rule? And if you can't find the general rule, at least explain the pattern that you've made in the table. Also, how does the snail problem help you solve part B? All of these questions are quite similar. And lastly, explain how using composite equations allows you to find the number of people who can be seated. So as you can tell by looking at all those things, they're all fairly similar type questions, but it's just a bit of you giving a bit of an explanation to say how you worked and what you did, and any of the problems you had or anything you found a bit tricky. That you can include that in your video as well. Make sure your video only goes for about a minute, no more than 2 definitely. A good way of doing it is doing what I'm doing. I just explain everything, but there's a few other screencasting things out there that you might like to use that you can, where you can get a picture, like I've done at the